To simplify algebraic expressions, we remember that we need to combine our like terms. We can identify like terms because they are going to have the same variable being raised to the same power. Constants, which are terms without variables, are all like terms because they can be combined with each other as well. So let's review an algebraic expression. In this expression, 5x to the second power plus 3x minus 5, we see that 5x to the second power is a term, 3x is a term, and 5 is a term. We know that they're terms because they are separated by the plus and minus signs. In 5x to the second power, 5 is the coefficient of x because 5 is being multiplied by x. In 3x, 3 is the coefficient because it is being multiplied by x. In both of those terms, x is the variable. On 5x to the second power, we see that x has a power or an exponent of 2. But 3x does not have that. Because of that, these two are not like terms even though they have the same variable. I also noticed that in my last term of 5, this is a constant. There is no variable with 5. Because none of these are like terms, I could not simplify this expression any further, so 5x to the second plus 3x minus 5 is in simplest form. Now let's look at some other expressions. This expression says 6g plus 9 minus 8g plus 5. If I am going to simplify this expression, I need to identify my like terms. My first term is 6g. I notice that I also have 8g in my expression. These are like terms because they share the same variable and that variable is being raised to the same power. I notice that in front of 8g, I have a minus sign. Now this can mean two things. I can consider this 6g minus 8g, or I consider 8g a negative 8g, and I can say 6g plus negative 8g. Either way, I would get the same answer. So if I write it just the way that it's written, I see 6g minus 8g. Well, we remember that when we are subtracting with integers, we always change subtraction to an addition problem. So this really would be 6g plus, and then I need to find the opposite of 8g. The opposite of positive 8g is negative 8g. Now I would just add my terms. Well, I have a negative plus a positive, which means I actually need to subtract my absolute values. So I would subtract 8 minus 6, which would give me 2, and I would keep my variable of g. Since 8 is larger than 6, I'm going to keep the sign from 8, which is negative. So 6g minus 8g will give me negative 2g. Now that these have been combined, I can take them out of my expression and I can find other like terms. I notice that I have a positive 9. I know that it's positive because there is a plus sign in front of it. And then I also have a positive 5. Well, this is the same as saying positive 9 plus 5. When I solve 9 plus 5, I get a value of 14. Since that 14 is positive, I am going to write plus 14. So the simplified expression is going to be negative 2g plus 14. Let's look at another expression. This expression says negative 9f plus 19 minus 7 plus f. I'm going to find like terms, so I'm starting with negative 9f. I notice that I have an f over here, which means these are like terms. To combine them, I'm going to look in front of this f. I see that it's a positive f, but this also means negative 9f plus f. I'm going to add these terms, and I know that even though I don't see anything in front of my f, there is actually an invisible 1 here. So really, I'm adding negative 9 plus positive 1. When I add negative 9 plus positive 1, I get negative 8. And then I'm going to keep my f. So negative 9f plus f gives me negative 8f. Now these will go away from my expression because I have combined them. And now I notice that I have two constants. I have 19, and technically I have a negative 7. This is also the same as saying positive 19 minus 7. If I solve 19 minus 7, I get 12. This 12 is positive. So when I write it in my expression, I'm going to write plus 12 to show that my 12 was positive. So my simplified expression is negative 8f plus 12. Now let's try this one. 5x minus 9 plus 13x minus 2y plus 7 plus x. The first thing we're going to do is find our like terms. So I notice that I have 5x, and I also have a plus 13x and plus x. Well, to simplify these, I'm going to add them together because each of these has a plus sign in front of them. So 5x plus 13x plus x. And even though I don't have a coefficient on my x here, I know that there is an invisible 1. So 5x plus 13x is 18x, and then 18x plus 1x is 19x. So when I combine those like terms, I get 19x. Now I can get rid of these because I have combined them, and I can look at the other parts of my expression. The next term that I see is not 9. It's actually, because of this minus sign, a negative 9. So I'm looking for any other constants in my expression. Negative 2y is not a constant because it has this variable of y with it, but I do have plus 7 here. So to combine these, I'm going to solve negative 9 plus 7. If I add negative 9 plus positive 7, I get negative 2. Because this 2 is negative, when I write it in my expression, I'm going to write minus 2. We do not want to write plus negative 2 because we don't want to have two different signs. Instead, if our solution is positive, we would write plus, and if our solution is negative, we would write minus. Now our negative 9 and our positive 7 have been combined, and the only term I have left is this negative 2y. Now my negative 2y does not have any like terms, but that doesn't mean I ignore it, and instead I'm just going to rewrite it in my expression. Since it has a minus sign with it, that means it's a negative, so I'm going to write it just that way in my new expression. So minus 2y. The simplified expression here is 19x minus 2 minus 2y. Now let's simplify this expression. You'll notice that we have parentheses here. And a lot of people get confused because they look inside the parentheses, and the order of operations does tell us to solve what's inside of parentheses first. However, if you look inside the parentheses, 2a and b are not like terms, so they could not be combined. And in this parentheses, 8a and 11 are also not like terms, so they can't be combined. But what we do notice is that each of these sums and differences inside of my parentheses is being multiplied by a constant on the outside of the parentheses. This tells me that I can use the distributive property. I'm going to distribute for this first one 6 into every term inside of my first parentheses. This means that I'm multiplying 6 times 2a, and 6 times 2a gives me 12a. I'm also multiplying 6 times the coefficient of b. Again, it looks like there is no coefficient here, but there's an invisible 1 hiding here. And I also need to be very careful here. I'm not actually multiplying 6 times 1. I'm really multiplying 6 by negative 1 since I can see this minus sign here. So this is positive 6 times negative 1b. Positive 6 times negative 1 is negative 6. So this is going to be negative 6b. To show that my 6 is negative, I'm going to write minus 6b. Now let's go to my second set of numbers, and let's go ahead and distribute this 3. I'm going to multiply 3 times 8a, and then I'm also going to multiply 3 times 11. Well, this 3 is positive, which I know because there's a plus sign in front of it. So positive 3 times positive 8a is positive 24a. So I'm going to write plus 24a. Then 3 is being multiplied by positive 11, which I know because this plus sign is here. So positive 3 times positive 11 is positive 33. So I will write plus 33. Now I always need to check my expression to see if it has any like terms and if it can be simplified. My first term here is 12a, and I notice that I also have 24a in this expression, so these can be simplified. So I'm going to combine 12a plus 24a, and when I add 12a plus 24a, I get 36a. So I'm going to write 36a, and now these are going to cancel. My next term is negative 6b. I don't have a like term for that, so I'm just going to rewrite it in my expression. Now I can get rid of it, and then my last term here is positive 33. It also does not have a like term, so I'm just going to write plus 33. So my simplified expression is 36a minus 6b plus 33. Let's try 3 times p minus 4 minus 12p. Again, I can't start inside my parentheses because there's nothing that can be simplified here. Instead, I need to distribute my 3 to every term inside of my parentheses. This is going to be 3 times p, and again, there's an invisible 1 here. So 3 times 1p is 3p. Then I'm multiplying 3 by not 4, but this minus sign tells me that it's a negative 4. So positive 3 times negative 4 equals negative 12. To show that my 12 is negative, I'm going to write minus 12 in my new expression. Now, that means that I have simplified this piece of my expression, but I still have this minus 12p that's over here, so I'm going to rewrite it. Now I need to look at my expression and see if there's anything that can be simplified. I see that I have 3p and negative 12p. So I need to simplify these by doing 3p minus 12p. If I solve 3p minus 12p, I get negative 9p. So I'm going to write negative 9p, and then these are going to go away. I still have a constant of negative 12 in my expression, so I need to rewrite this. Now, my expression is fully simplified, and it's negative 9p minus 12. Let's look at this expression. I see that I have a 5h and a negative 3, but they can't be combined in any way yet. I also notice that I have 2h minus 4 in parentheses, which also cannot be simplified, but it's being multiplied by this number out here. That means I can distribute this to every number inside of my parentheses. Now, I have not done anything with 5h or with negative 3, so I'm going to go ahead and rewrite those so I don't forget about them. So I'm rewriting 5h and I'm rewriting negative 3. Now I can focus on distributing over here. When I distribute, I need to be very careful. This number is not 12. There is a minus sign in front of this 12, which means that this is actually a negative 12. So when I solve, I'm going to do negative 12 times positive 2h. Negative 12 times positive 2h is negative 24h. Because it's negative, I'm going to write minus 24h. Then I'm going to distribute negative 12, not to 4, but this sign right here tells me that this is a negative 4. So I'm multiplying negative 12 times negative 4, which gives me positive 48. To show that this is positive, I'm going to write plus 48. Now, all I have to do is simplify by combining any like terms. My first term is 5h, and I see that it can be combined with negative 24h. So I'm going to do 5h minus 24h. And when I solve 5h minus 24h, I get negative 19h. So I'm going to write negative 19h, and then I'm going to get rid of these because I've combined them. Next, I see that I have negative 3 and positive 48. So to simplify these, I'm going to add negative 3 plus 48. When I add negative 3 plus positive 48, I get positive 45. Since it's positive, I'm going to write plus 45 in my expression. So my solution is negative 19h plus 45. Now we can use what we learned to write and simplify expressions for real-world situations. In this case, I have a rectangle and I need to find its perimeter. Well, I know that to find the perimeter of a rectangle, I would add up all the sides. It looks as if they only gave us 2 side lengths, but I know that this side length is 2x and this side length is 3x plus 7. So to find the perimeter, I can do 2 times my length is 3x plus 7, plus 2 times my width, and my width is 2x. And then I can distribute and simplify. If I distribute my 2 here, 2 times 3x is 6x, and 2 times positive 7 is positive 14. Then I would be multiplying this positive 2 times this 2x. So 2 times 2x is positive 4x. Then I would combine my like terms. I see that I have 6x plus 4x, which gives me 10x, and then I have a constant of 14. So the perimeter of this rectangle would be 10x plus 14. If you don't want to do this with the distribution, you don't necessarily have to. You can look at this as if it is 3x plus 7 plus 2x plus 3x plus 7 plus 2x. In this case, there's no distribution that needs to happen, and instead, we would only need to combine like terms. Well, I would have 3x plus 2x, which is 5x, then plus 3x, which is 8x, and then plus 2x, which is 10x. Then we also have positive 7 plus positive 7, which is 14. So either way, you're going to still get a perimeter of 10x plus 14. Now let's look at this pentagon. To find its perimeter, I am going to add up all of the side lengths. I see that I have 2 side lengths that measure y plus 2. So I can represent this by saying 2 times y plus 2. And then I can add it to my next side lengths. Well, I also have 2 side lengths that measure 2y minus 1. So I can multiply 2 times 2y minus 1. Then I have a 5th side length that measures 3y. Now to solve this, I'm going to distribute my 2 here. So 2 times y is 2y, and 2 times positive 2 is positive 4. I'll also distribute this 2. So 2 times 2y is positive 4y, and then positive 2 times negative 1 is negative 2. So I would write minus 2. Then I still have plus 3y that needs to be written. Now I would combine like terms. I have 2y plus 4y, which is 6y, then plus 3y, which is 9y. Now those have been combined, and now I'm going to look at my constants. I have positive 4 minus 2. 4 minus 2 is positive 2, so I would write plus 2. So the perimeter of this pentagon can be represented by 9y plus 2.